Hey guys, today in Algebra 1 we're going to be talking about solving literal equations in dimensional analysis. Now it sounds a little intimidating, but all it is solving equations when there's more than one variable present. So on number 1 we have 4x plus 2y equals 6. They want me to solve for y, so I need to get this guy over here all by itself. Now if you'll remember, when solving equations you work through the order of operations backwards, which means we need to handle any addition or subtraction before any multiplication or division. So with this y, first we see that there's a 4x being added to it. So to get rid of that, we're going to subtract 4x from each side. Now on the left side, those 4x's are going to cancel out and leave me with just my 2y. On the right side of the equation, I have a 6 and a negative 4x. Now those are not like terms. The 6 does not have an x to the first power, so I cannot combine them together, which means they have to stay separated. But what's important is we want this term with the x to go first. I want that to go in front of the 6. So we want to write that as negative 4x plus 6 instead of 6 minus 4x. So very important, when solving for y, the x term always needs to go first. Next, I want to divide each term by 2 because we're multiplying by 2 here. So divide this term by 2, this term by 2, and this term by 2. So on my first term, 2y divided by 2 leaves me with y. Negative 4x divided by a positive 2 leaves me with a negative 2x. And a positive 6 divided by a 2 is a positive 3. So when solving for y, your goal is to get y all by itself on one side of the equal sign. Here we see that that's done, and so y is equivalent to negative 2x plus 3. Even though that's not just one simple number like y equals 5, it's okay because y is by itself. So on number 2, we want to get y all by itself on one side of the equal sign. So handle any addition or subtraction before any multiplication or division. So this 21x is attached to this negative 7y. So I want to subtract 21x from each side because it's a positive number. That's going to cancel off on my left side, leaving me with the negative 7y. So be careful with that sign. Negative 7y on the left-hand side. And on the right-hand side, these are not like terms, so I cannot combine them. It's going to look a lot like number 1. The x term needs to go first, so negative 21x plus 14. Next, I want to get rid of the negative 7 that's being multiplied by y, so I'm going to divide each term by negative 7. Negative 7y divided by negative 7 just leaves me with y. A negative 21 divided by a negative 7 is a positive 3, and then bring down my x. And then a positive 14 divided by a negative 7 is a negative 2. So once you get y all by itself, that's when you know that you're done. So on number 3, again, we want to subtract that 13x first from each side. And we are left with a positive 13y equals, the term with the x goes first, so negative 13x minus 39. Then we divide each side, or each term, by 13. So 13y divided by 13 leaves me with y. Negative 13x divided by 13 leaves me with a negative 1x, so I'm just going to write it as a negative x. And a negative 39 divided by a positive 13 is a negative 3. My pen would write a 3. So y equals negative x minus 3. Make sure you box your answer so it's easy to find where your solution is. Next, on number 4, again we want to solve for y, so I'm going to subtract 3x from each side, and the 3x's will cancel out, leaving me with a 2y on my left side. And on this side, the x term goes first, so negative 3x plus 24. And then I want to get the 2 away from the y, so we're going to divide each term by 2. So 2y divided by 2 leaves me with y. Negative 3 divided by 2 doesn't work out very well because 3 does not divide by 2. So we're going to leave it as a fraction, and we're going to make sure it's simplified. So 3 over 2 cannot be simplified. So that's going to stay as negative 3 over 2, and then I want that x to go next to it. Notice when you're dividing, it kind of looks like it's a part of the fraction. I want, when you rewrite it, the x to be next door to it. So not in the numerator with a 3, not in the denominator with a 2. I want it to say negative 3 halves times x plus 24 divided by 2 is 12. So when you have fractions, make sure you leave them as fractions, simplify them all the way down, and make sure they're improper. So y equals negative 3 halves x plus 12. On number 5, we're going to start again by subtracting 3x from each side. That'll cancel out, and make sure you leave this sign with the y. Negative y equals, the x term goes first, negative 3x plus 7. Oh, that's not a 7. That's a 7. Now, I want to get the y all by itself, and currently it has a negative sign in front of it, which means it's being multiplied by negative 1. So we are going to divide each term by negative 1. Negative y divided by negative 1 is a positive y. Negative 3x divided by negative 1 is a positive 3x. And a positive 7 divided by a negative 1 is a negative 7. So y equals 3x minus 7. On number 6, we're going to subtract. Be careful here because I switched the order of the variables. We still want the y by itself, so I need to subtract the 2x from each side. And that's going to leave me with a 3y equals negative 2x plus 18. And then we'll divide each term by 3. So 3y divided by 3 is y. Negative 2 divided by 3 doesn't work, so we need to leave it as a fraction and make sure that it's simplified. So negative 2 over 3 cannot be simplified anymore, so I have a negative 2/3, and the x needs to go next to it, plus 18 divided by 3 is 6. So y equals negative 2/3 x plus 6. On number 7, again, we want to get that x term away, so we're going to subtract x from each side. And I'm left with negative 2y equals negative x plus 1. And then I need to divide each term by a negative 2. So negative 2y divided by negative 2 is y. Here I have a negative over a negative, which means that's going to cancel out and be a positive. But the term in front of the x is a 1 over a 2. Now 1 over a 2 cannot be simplified, so that's 1/2. Bring your x along for the ride. And then I have plus 1 over negative 2, which is like a negative 1/2. So I'm going to say minus 1/2. So be careful with that term in front of the x. It's a 1. It's imaginary. You can't see it. Number 8, ooh, they switched some things around, but that's okay. Now our variables are on this side, so I want to subtract 10x from each side. And I still want that x term to come first, so I still want to write it as negative 10x plus 25 equals 5y. And then I want to divide each term by 5. So negative 10 divided by 5 is negative 2x. 25 divided by 5 is positive 5. And 5 divided by 5 leaves me with y. Now you can leave your answer like this, or if you're picky like me, you can switch it so the y comes in front and says y equals negative 2x plus 5. Each way is technically correct. Now what I'd like you to do is pause the video and do number 9 on your own. Okay, so on number 9, you should have gotten y equals negative 9/4 x plus 11. What's important is that you watch your signs, so when you subtract, or when you add the 9x over, it becomes positive, and then you divide each term by a negative 4. So 9 over negative 4 doesn't simplify. It stayed as negative 9/4. And then a negative 44 divided by a negative 4 gives me a positive 11. All right, next what we're going to talk about is what happens when we're solving equations with different kinds of variables. So before we start, what's very, very important is whatever kind of variable they give you, if it's a lowercase d, if it's a capital A, if it's a lowercase cursive L, if it's a lowercase cursive W, if it's an M, you need to leave it exactly like they gave you. If it's capital, it stays capital. If it's lowercase, it stays lowercase. If it's cursive, write it as cursive. When you change the way that variables are written, you're changing what they stand for. So it says solve the following equations for the indicated variable. So in number 10, we have d equals r times t, and they want you to solve that for the variable t. Well, right now, t is being multiplied by r. So to get t by itself, we need to divide each term by r. On the left side, d over r doesn't simplify. They're two variables, they stay that way, so d over r. On the right side, these r's are going to cancel out and just leave me with t. So my goal was to get t all by itself on one side of the equal sign, and I've done that. T equals d divided by r. On number 11, I have capital P equals 2 times lowercase l plus 2 times w. They want me to solve that for w. So first I need to add or subtract before I multiply or divide. So added to this w is a 2l. That means I need to subtract 2l from each side and make sure that's lowercase and cursive. So on the left side, I'm going to start with a p minus a 2l, and on the right side, I'm going to be left with 2w. Now, when we were working with x's and y's and solving for y, I said it was very important that your x term was written first. On these kinds of problems, we're working with all sorts of different variables, so it doesn't matter which term you put first, whether it be the p minus 2l or negative 2l plus p. That's your decision, and either way is okay. Next, to get w by itself, I need to divide that 2 away from it. So I'm going to divide each term by 2. So my first term here is 1p over 2. So 1 over 2 simplifies to 1/2, and then the p goes next to it, minus 2l divided by 2. Those cancel out and leave me with an l, equals 2w divided by 2. Those will cancel out and leave me with a w. On number 12, I have a capital C equals d times pi. They want me to solve for the d variable, which means I need to get this pi that's being multiplied away from that d. Now to undo multiplication, we need to divide each term by pi. So on the left side, I cannot simplify capital C over pi. That can stay capital C over pi. On the right side, those pi's will cancel out and leave me with a lowercase d. So now that the d is all by itself, I have c over pi. On number 13, I have k times n plus 4 times f equals v, and they want me to solve for n. So this variable right here is what they want me to get all by itself. So first I need to add or subtract, so I want to get rid of this 4f being added to it. So I'm going to subtract 4f from each side. Now on the left side, those will cancel out and leave me with k times n. On the right side, again, I don't care which order you put it in. If you want to put it in alphabetical order, if you want to write it so it's easier to write, that's fine with me. I'm going to go 9v minus 4f. Then finally, to get that n by itself, I need to divide each term by k. So here, the k's will cancel out, leaving me with n. This one, 9v over k, since I'm dividing by a variable, I can't simplify, so 9v over k, minus, again I'm dividing by a variable, so 4f over k. Now it's very important that you divide each term, not the sides, each term. Number 14, 8c plus 6j equals 5p. I want to solve that for c. So I need to subtract first, and I'm going to be left with 8c equals 5p minus 6j. Then I need to divide each term by 8. Now notice here we're dividing by a number, so there's going to be some simplifying going on. So these cancel out and leave me with a c equals 5 over 8 cannot be simplified, so we're going to write that as 5 over 8 times p minus 6 over 8 can be simplified. 2 can go both into 6 and 8, so that's going to be a 3/4 j. And then we have our variable all by itself, so we box our answer. Now on number 15, I have a equals 1/2 times b times h. They want me to solve this for h. Now notice, we have a fraction in this equation, and fractions are very, very tricky to work with. So the first thing I want to do is eliminate that fraction, which means I'm going to multiply my entire equation by the denominator, which is 2. Now 2 times a gives me 2a, and then 2 times 1/2 base times height cancels out that 1/2 and just leaves me with base times height. Now, to solve for h, we just need to get that b away from it, so I'm going to divide each term by b. And that's going to leave me with 2 times capital A over b equals h. Now that the h is all by itself, we'll box your answer. Next, we have x minus c over 2 equals d. They want us to solve for c. Now, if you'll notice, we have a 2 in the denominator here. I want to get that 2 away from this equation first before I can start solving for c. So I'm going to multiply each side by 2. Now on the left side, this is very important, the 2 only cancels out the denominator. It does nothing to the numerator. So on the left side, it leaves me with x minus c. On the right side, I have d times 2, which gives me 2d. Next, I want to get c by itself, so I'm going to subtract this x from each side, and that leaves me with negative c equals, if you want to put 2d minus x or negative x plus 2d, I'm used to, when I see an x, putting it first. So I'm going to go ahead and say negative x plus 2d. If you wrote it the other way, that's fine. Go ahead and leave it. Next, what I want to do is get this negative 1 away from this c. So I'm going to divide each term by negative 1. And a negative c divided by a negative 1 is a positive c, equals a negative x divided by a negative 1 is a positive x, and a positive 2d divided by a negative 1 is a negative 2d. On number 17, I want to solve for p. Notice p is in the numerator again. So the first thing I need to do is get rid of this denominator. So I'm going to multiply each side by that denominator of 5. On the left side, it cancels out that denominator and only leaves me with the numerator of p plus 9. On the right side, 5 times r is 5r. Next, we're going to subtract 9 from each side, and I'm going to be left with p equals 5r minus 9. Alright, next what I'd like you to do is pause the video and do number 18 on your own.